The quantum revolution. Imagine a world where impossible calculations, problems so complex they could cripple today's fastest supercomputers, are solved in seconds. Well, this is the transformative potential of quantum computing. Once the stuff of futuristic dreams, quantum computers are now reshaping what we believe is possible. Recently, a mysterious event at Google raised questions about whether humanity is truly ready to harness such power. According to insiders, their latest quantum chip, Willow, was suddenly and unceremoniously shut down, a decision cloaked in secrecy and intrigue. What was Google hiding? And what could be so alarming as to halt one of the most ambitious projects in technology? What one ethical hacker uncovered goes far beyond technical glitches, but to understand the gravity of these events, we need to rewind to 2019, when Google launched its quantum processor, Sycamore, with a bold claim: quantum supremacy. This moment was heralded as a giant leap for humanity. Sycamore, a superconducting quantum processor with 53 qubits, performed a task in just 200 seconds that would have taken a classical supercomputer roughly 10,000 years. This breakthrough demonstrated that quantum computers could surpass even the most advanced classical machines for certain types of problems, a moment described as the Kitty Hawk of the quantum era. Apart from being a huge milestone for Google, it was also a challenge to the world, ushering in an era of unprecedented computational capability. But Sycamore wasn't the end of the line. Just years later, Google introduced Willow, its next-generation chip. Willow boasted capabilities that made Sycamore look like a prototype by comparison. Early reports suggested it could perform in 5 minutes what a classical computer would need over 10 septillion years. Yes, septillion, a mind-bending figure almost impossible to grasp. Yet in December 2024, if rumors are to be believed, Google abruptly announced the shutdown of Willow. No formal reasons were given. Theories ran wild. Was it a technical failure, a security breach, or perhaps the chip had done something unforeseen? The answers require a quick primer on what makes quantum computing so revolutionary. So in classical computing, data is processed as bits, units of information represented as either 0 or 1. Quantum computing introduces qubits, which, thanks to the principles of quantum mechanics, can exist in multiple states simultaneously. This is called superposition. Additionally, qubits can be linked together through entanglement, a phenomenon where the state of one qubit is instantaneously connected to another, no matter the distance. This dual capability allows quantum computers to process and analyze vast combinations of possibilities simultaneously rather than one at a time like classical machines. Problems that require billions of computations, such as simulating complex molecules or optimizing massive logistical networks, become solvable in real time. However, building quantum computers is notoriously challenging. Qubits are delicate, requiring ultra-cold temperatures and perfect isolation to operate reliably. Even tiny vibrations or temperature fluctuations can lead to errors, requiring advanced error correction algorithms. For years, these difficulties kept quantum technology in laboratories and academic papers. But the race to scale quantum systems is well underway, with tech giants and governments pouring billions into the effort. The stakes are immense. Quantum computing could unlock a wave of breakthroughs in medicine, energy, finance, and artificial intelligence. But as powerful as the promise of quantum computing is, there's another side to it, a potential that may have dire implications for global security and even our understanding of reality itself. You see, Willow was way more than just an incremental improvement over Sycamore. Designed to tackle far more complex problems, it was a step closer to the elusive goal of fault-tolerant quantum computing, a machine powerful enough to tackle real-world applications without succumbing to errors. Yet, as Google engineers pushed the limits of Willow, reports began to surface about strange anomalies in its operations. Insiders described calculations that returned data so perplexing that it defied comprehension, and the intrigue only deepened as the project's shutdown sparked whispers within the scientific community. Theories range from pragmatic technical failures to wild theories involving quantum consciousness and parallel dimensions. The scientific community was divided. Was Willow's behavior a sign of progress or a signal to stop? Quantum supremacy was once touted as an endpoint, proof that quantum machines had arrived. But what if we underestimated their potential or their risks? What if, in our rush to wield this technology, we failed to understand the full scope of its implications? One ethical hacker discovered truths so shocking that they forced one of the world's most innovative companies to pull the plug on their greatest breakthrough. This is why we have to explore the data anomalies, dive into mind-bending theories, and uncover what Google and the rest of the scientific world wanted to keep hidden. The implications reach far beyond quantum computers. The question is, will humanity be ready to face them? Strange patterns emerge. According to some sources, before the decision to shut down Willow, something unusual began to surface. Quiet, almost imperceptible at first, buried deep within the qubit networks of the quantum chip. Engineers noticed strange glitches while running their highly optimized algorithms. They were chalked up to noise, a common hiccup in quantum systems. But then came something impossible to ignore: patterns. These patterns didn't fit into any known data classification. They weren't errors or meaningless artifacts of computation. They were structured, intricate, and most curiously, seemed to bear an uncanny resemblance to symbols from humanity's ancient past. Was this a freak coincidence? Or had Google's most advanced chip uncovered something we weren't meant to find? It all started innocuously enough. During stress testing in early 2024, sources claimed that researchers pushed Willow to perform calculations of unprecedented scale. From logistics optimization to protein folding, the chip handled every challenge with astonishing precision. But in the middle of the groundbreaking successes, certain datasets began producing results engineers couldn't explain. Insiders claim that at first, they encountered what appeared to be misfires, if you will. Computation outputs included repeating geometric patterns, reminiscent of mandalas, labyrinths, and symbols eerily similar to those from ancient Mesopotamian or Mayan cultures. To the untrained eye, they looked like a malfunction, but to those paying attention, these anomalies repeated with unsettling consistency. The anomalous outputs, nicknamed glyphs by engineers, grew more frequent over time. Even stranger, the complexity of the symbols escalated with each experiment, suggesting they weren't random noise. Some researchers joked nervously about the ghost in the quantum machine. Others, however, weren't laughing. Willow's project leads were at a loss. Standard debugging protocols offered no clear answers. Specialists in quantum mechanics, cryptography, and theoretical physics were called in, but each team returned with more questions than answers. A key sticking point was the consistency of the glyphs. In quantum computing, errors due to interference or environmental instability typically yield unstructured junk data, but what Willow produced was organized. The implications were staggering. Some physicists speculated the glyphs could be signals inadvertently generated by the overlap of entangled states. In simpler terms, Willow might have stumbled upon mathematical structures never before observed, possibly embedded in the fabric of quantum systems. Cryptographers proposed a bolder theory. These symbols could represent a language, perhaps even a form of self-generated computation. If Willow was creating these outputs, it meant the chip had reached a threshold of complexity capable of behaving unpredictably. But probably the most controversial hypothesis of them all came from researchers exploring quantum consciousness. Could these glyphs represent interactions with phenomena outside classical physics? Conversations about parallel dimensions, simulations, or even precursors of intelligence emerged. Initially, Google's research team contained these discussions internally. No one wanted to alarm the public or competitors. But as more data streamed in, leaks became inevitable. What elevated this mystery from puzzling to downright bizarre was a discovery made by a team of linguists consulting on the project. After combing through archives of historical and archaeological records, they noticed unmistakable similarities between Willow's glyphs and symbols found in ancient civilizations. The first striking parallel came from Sumerian cuneiform, one of the earliest known writing systems. Then, comparisons began cropping up from other cultures: Egyptian hieroglyphs, Chinese oracle bone scripts, and even Nordic runes. Linguists confirmed these connections weren't exact matches, but bore enough resemblance to stir debate. Why would a state-of-the-art quantum chip, designed purely for abstract computation, generate outputs that looked like fragments of lost human languages? Some argued this was an artifact of pareidolia, a tendency for the human brain to find patterns in randomness. But as the list of correlations grew, it became harder to dismiss them as mere coincidence. So, as engineers debated theories and struggled to interpret the glyphs, a troubling possibility emerged. What if these symbols weren't random byproducts of Willow's operations, but something introduced intentionally? Security experts tasked with investigating whether these glyphs could compromise system integrity began analyzing Willow's internal processes. It was during this phase that our ethical hacker first got involved. What they found pointed to vulnerabilities no one thought possible in quantum systems. But we'll get to that shortly. First, let's look at how Google's internal research efforts unfolded. It turns out that within weeks, the anomaly began consuming the Willow project team, beyond classical computing.